1.8 linear equations.
I can use.
I could use slope intercept to solve linear equations.
Good. So, we're using slope-intercept form to solve linear equations. Linear means what again, everybody?
Line.
It means line. We're talking about a straight line. So, a linear equation would be graphing a straight line using what? Using what, you guys? Using ordered pairs. So anytime you put a dot on a graph or a point on a graph, we use ordered pairs to find that point, right? Right? All right, so we need to know what slope is. What is slope? Rise over run. What is the variable that we use for slope? M. We'll talk about that in a second. What is y-intercept, you guys? No, what is y-intercept? Where the line crosses the y-axis. So if this is a y-axis, that's the x-axis. If we have a line crossing right here, that's where it intercepts the y-axis, because y to the sky, that's the y-axis, right? Okay? And then the letter we use for y-intercept is what? B. And when I'm talking about these letters, we go down to the slope-intercept equation, and we have it all labeled up here. We already said B is the y-intercept, right? M is the, and then what is the x? And what is the y? So the x and y coordinate, the ordered pairs that I was just talking about. All right, and then slope goes by a whole bunch of different names. We said slope is called, and this one is just something to know. We're not going to talk about it much for the rest of the year. And then slope determines how steep a line is. And then what we did for number 4 is we used a graph to write y equals mx plus b. So if I go to, so if we go to a problem like number 9 here, you guys, I gave you this graph, yes or no?
Yes.
And I asked you to write the slope-intercept equation, right?
Yes.
And that's the answer right there. So did we do anything for y? Did we do anything for x? Y and x, so here's your slope-intercept equation. Y and x always stay y and x, because it could be a whole bunch of different things. But m and b are what we need to fill in. So we said b was what?
1.
How do I get 1? Someone raise your hand and tell me, how did I get 1, Swara? So this green line right here that I'm drawing again crosses the y-axis. This is the y-axis at what point? 1. I go up 1 spot, right? How did I get the slope of 2 over 1? How did I get a slope? Raise your hand, somebody, and tell me, how did I get a slope of 2 over 1? Jake?
Because you rise 2 and left over 1.
So another point on my graph is right here, right? So if I have this point and this point, I'm going to use a different color. If I have this point and this point, how do I get from the bottom one to the top one? I rise how far?
2.
And I run how far?
1.
So a rise of 2 and a run of 1, and that is my slope. So my slope-intercept equation, no, nothing for y, nothing for x. M becomes your slope, and b becomes your, what's b?
1.
Y intercept. Okay, does that make sense? Okay. Our last example is I asked you to graph this equation. All right, all eyes up here.
Yes.
I asked you to graph this equation. Melissa, how did we do this? How did we get this line, because we actually graphed this line that I'm outlining in green, using this? What did you do first, Melissa?
We found where the y-intercept.
What is the y-intercept?
1.
So this line is crossing the y-axis at point
1.
what?
1.
1. It goes 1 up on the y-axis, right? Okay, and then how did we get this point right here, Melissa?
Well, we rise 3,
We rose 1, 2, 3.
and then we ran 4.
1, 2, 3, 4, right?
Yeah.
And then we got another one right up here, yes, no?
Yeah.
We rose what?
3,
And we ran what?
4.
And we could keep doing that forever and ever, right? So graphing, all you gotta do is find the y-intercept first, and then continue to find points using the slope, or the rise over the run. Make sense?